Shaya. I'm Dr. Deepti Menon, working as professor at the Nanobioengineering and Drug Delivery Group of Amrita School of Nanosciences and Molecular Medicine at the Kochi campus of Amrita Vishwavidyapeetham. To talk about my journey in science this far, it all began when I got into the prestigious Indian Institute of Science as a research scholar in the Department of Physics way back in 1995. It was my passion in science, especially in physics, that led me to this prestigious institute. When I joined the institute, the number of girls who were present in the department were far and few. The passion from within that ignites a person into research. And I feel that if you are passionate about something, you can achieve it. And that requires perseverance, commitment, and above all, passion. Passion is the most important feeling that one should have to progress in life, to achieve success. So it is never gender biased. Whether you are a boy or a girl, if you are passionate about something, I'm sure you can achieve it. And when I joined Amrita in 2006 as an assistant professor and thereafter started off my career, I could see that it was more number of girls who joined PhD. And I was quite excited about it to actually drive them forward. And when I stand today in 2022, I've already guided 12 PhD students, of which 9 of them are girls. So, in my view, there is no gender in research or science. Women should also be equally motivated, allowed to pursue their interests and passion. And I think government has come up with a lot of opportunities to actually promote women in science. All of the girls around who are interested in any kind of their own fields should actually take up the opportunities which are extended by Indian government in various platforms. The field of material science is an old domain. Physics, material science are all fundamental subjects. But where does it lead to now? The current trend is more towards advanced materials, more functional materials, which can be utilized for diverse applications, whether it be in the field of medicine or engineering, agriculture, name any field, you can utilize materials. And the current trend is towards miniaturization. And that is where nanotechnology makes its impact. And thus the field of nanomaterials have actually come up in a very big way over the past 2 decades. Actually, it is this quantum leap in nanotechnology that we material scientists are trying to capitalize on for the field of biology in general and medicine in particular. Because as you all know, there are varieties of ailments which are actually looking for solutions. So being under this umbrella of a super specialty hospital, that is Amrita Institute of Medical Sciences, and where we have come in as material scientists, this association between scientists at Nanosciences Center and the clinicians at Amrita Institute of Medical Sciences has indeed made a big change in this field. And that change is what we scientists have tried to capitalize on. So we are actually into the field of nanobiomaterials, the use of nanomaterials for diverse applications in biology, and I said in medicine particularly, whether it be for cancer diagnosis, cancer therapy. You know, the ailment cancer is actually the buzzword now. And so there is necessity that people come together in various fields and make an impact in this particular field to bring about a change in the modes of therapy, in the mode of diagnosis, as well as in various other fields of tissue engineering and regenerative medicine. So when you put it all together, I think that it is a basic training that I have gained in material science that has actually helped me to come up with novel and innovative ideas that can bring about a big change. And it is with this intention that we actually moved on towards the field of nanobioengineering, wherein you can actually tune materials at the nanoscale, that is at the scale which is not really seen by a human eye. At very, very small scales, we are able to tune the material such that we can capitalize on its benefits or interactions at the cellular level. So we are actually bringing in a marriage between materials and biology, which can actually benefit the field of nanobiotechnology and nanobiomedicine. When I see that the students who come in to do PhD at this center, the girls are more in number, I would actually expect that this number keeps on rising as time goes by. And after a PhD, it should not mark the end of a career for a women scientist. It should actually mark the beginning of a new journey ahead. What we notice is the statistics. If you look into the Indian science community, you can see that more number of men dominate this field. It is for us women to empower ourselves and move on further to bring up the change that is very much required. And I feel that the workforce, the women workforce, can actually do a lot of good things to the society and bring about all kinds of innovative themes which can benefit humankind in general. Just to give you an overview of the kind of work that we do at Amrita School of Nanosciences. In my lab, we actually focus on the use of different kinds of nanomaterials for biological applications. Especially when I say biological applications, I mean the interactions with tissues and cells in the human body. So with the vision of translating the work towards a product for a scientific use. That's the ultimate goal with which we work. We have been working with nanoparticles, nanofibers, and different kinds of nano-engineered surfaces. When I say all this, we can utilize nanoparticles for applications in diagnosis of diseases, to deliver drugs to a localized locations. For example, for treating diseases like cancer, that is a localized drug delivery can be made possible with the use of nanomaterials. Same way, we can utilize nanofibers, which are very, very thin fibers in comparison to even our human hair. So it is these fiber-like materials that we utilize most recently to develop nanomask. These fibers actually helped to trap the virus particles, the coronavirus particles. And with that, we could filter the coronavirus and protect the person wearing the mask from the disease. So just to talk in layman's language, we are talking about very small material at the nanoscale to bring about very big changes or very innovative ideas which can actually be utilized for diverse applications. Take for example these nanofibers, which are otherwise very, very weak in strength, can be bundled together and developed in the form of a thread. We called it a yarn. These threads were actually, once you have a thread, anybody knows that you can weave a textile. And that is where our group actually came up with nanotextiles. The concept, the true concept of nanotextiles. Why we called it nanotextiles was because we were using nanoscale fibers which were bundled together to bring about a nano yarn. And these were actually woven together into different forms and shapes and sizes for diverse applications. One such example is that of a vascular graft that we developed, which was impervious to blood or which did not allow blood leakage and which could be used in coronary artery diseases, wherein you are utilizing them for bypass grafting. You might have heard about bypass. So vascular grafts which are based on nanomaterials will allow the cells in the blood to attach and very uniformly form a natural tissue. And these, when made up of degradable materials, they can actually get regenerated, thus bringing in the concept of regenerative engineering. Materials of different kind can be maneuvered to suit the right application, And that is what we are doing here. And I'm really proud to say that many of the students who were trained under my guidance, especially girls, are now at very important positions or key strategic positions in various industries as lead scientists. Even at the Harvard Medical School, we have our students who are lead scientists. So I'm indeed proud as a woman to actually have led a team of majorly women, and I think they would make a big impact in science. Thank you.